Greetings, one and all, and welcome once again to the Foreman Deep Dive series. Gilvin here, hosting as always. And today we've got the wonderful Dmitri, also known as witlessb, who is going to give us a look at the recent changes in the Smart-Proxy core. There's been quite a lot of activity in the last month or two on this. A lot of it, I believe, driven by the Puppet 4 changes, but there's other good reasons as well. So Dimitri's agreed to come on and just give us a bit of a rundown on how things have changed, why they've changed, and how you can make use of it if you're developing on the proxy, or indeed if you're developing proxy plugins. So pretty much it's over to you, Dmitri. First of all, welcome to the Deep Dives. Thanks for coming back on again.
Thanks for the introduction, and thanks for having me again.
No, it's a pleasure. So do you want to just kick off with a quick summary perhaps of what we're going to look at? What are the changes we're going to dive into today?
So there were a number of changes in Smart-Proxy core which are related to how plugins are loaded, initialized, and ultimately enabled to get used by the Smart-Proxy itself. The process itself of loading initialization of plugins is quite a bit more structured now, and plugin developers have ability to override individual parts of this process. All in all, the changes that were made, well, they were driven in part by requirements of Puppet module, and particular changes required to support Puppet 4.0, but also they were based on the problems, issues, things like this that I noticed we encountered, well, myself and other developers who write these plugins.
Great. So I think I should just say this is obviously a live broadcast. If anybody watching wants to join in the discussion, I am watching IRC, # Foreman, or # Foreman Dev. You can ask questions there. We also have the Q&A app enabled. So if you want to ask questions from the Google event, that's absolutely fine as well. We will do our best to get those questions answered. So, okay, we've got a rough idea of what we're going to look at. I'll let you take it away, and I'll just jump in as and when things happen.
Great. Thanks once again. So the new process for plugin initialization and loading can be thought of as consisting of two parts, two phases. The first one is loading of plugin settings and manipulating the settings if you need to, also validating the settings, basically making sure that the configuration of the module of a module, plugin, or provider is valid. And the second phase is using the settings that we just loaded, verified, etc. We use those settings to define runtime, and by that I mean load classes that we need to start. There is now a new concept of a service which I'm going to be talking about later. So you can launch services and things like this. So basically, you will have a runtime that's ready to be used by API or what have you. So now let's look a little bit closer into the process itself. So the first thing that we do when we're loading and initializing plugins is we go over all the plugins that we can find, and those are main plugins. So modules can be plugins or providers, and plugins are main modules. So they basically the bits that expose some API. So for example, we have DNS module plugin, DHCP plugin, etc. So we go over those, and for those that are enabled, we just collect them. the classes that represent those plugins, the ones that you use to define things like I don't know, backup paths, plugin names, like etc. etc. And once we've done that, for each of those, we load their settings. And at this point of time, what we do, the settings that we load are the ones that are placed in the each module's configuration file or default settings. Yeah, there are no changes at this point. So the next bit is we load dependencies. So if you wrote plugins before, there used to be, still actually is, so you can still use the older model of developing plugins. There used to be after activation block where you used to require all the files that define various classes that implement modules functionality. So now there is a dedicated phase for this. So if you should see my IDE now, and there is a new DSL for just that, load classes, and you specify the class that contains a very specific method, what we expected, that will do this loading for you. So for example, in this case, I'm looking at Puppet, main Puppet module. So here is this load classes, and we just require a bunch of files. Do note that we actually use an actual class name, or actual class rather than a string class name, because this way we need to be able to load it. So in other words, by this point, by the time we get this, the class should be resolvable. So for the rest of the changes, you can actually specify a string if you want, and we'll evaluate it during runtime to class. Again, this is because one of the first things we do, we load all the dependencies. So once that's done, we get a chance to programmatically define, redefine, change settings that were loaded. So I'm not particularly fond of this this command, this name, load runtime configuration. I think it's a bit ambiguous. So this probably will change. So here's an example of one of the simpler examples. It's again, this is a main Puppet module, and here's the change load runtime configuration. One of the things to help you with the changes is that the DSL that's used to define plugin or provider, these new changes, that they're exactly the same as the methods that will be expected. So for example, load classes, you may have noticed already, the method is load classes, and the same for a load runtime configuration, and it's the same for other changes. So one of the interesting things here is that, for example, we redefined or extended use provider setting, and we add additional providers based on another setting from the configuration file. So you can see it here. So based on the Puppet version, we either gonna use module that uses Puppet API, or we're gonna use older interface, which either scans directory with classes and environments or uses environments API. It's probably one of the simpler examples, easier examples. Really complicated one is in the Puppet Proxy Legacy module. I'll just show it very quickly to you. So you here it is. And
wow, you're not kidding.
well, Puppet module was complicated to begin with, and addition of or extending it to use Puppet API made it even more so. So that's what actually drove some of these changes. Anyway, so we define a bunch of other settings that will be used later on in the initialization and loading process. But here it is. The parameter into this method is the original settings that were defined in the configuration file plus default settings. So what's interesting here? I'm gonna go back to the main Puppet's configuration or main Puppet module. Notice here is a very quick validation of one of the parameters that we need for this to work. The bulk of validation happens later, and we're going to talk about it in a minute or two. So once we had a pass on defining or redefining or amending configuration, we can load, or actually will load, sorry, where is it? Let me go back to, yes, here it is. Oh, actually, it's not a good example because I'm not using it here. So yeah, the next phase, the next step in this phase is we're loading validators. So again, if you wrote a module or two or several, you know that there is very limited set of built-in validators for configuration settings. So those are one of the validators can check if a file exists and is readable, accessible to Smart-Proxy. And there's another one. Something else. Anyway, so now we have ability, or now you as plugin writers have ability to add your own validators and share them amongst modules, etc., etc. And the interesting bit is that the actual code to implement the validator is exactly the same as normal validators that ship together with Smart-Proxy. It's just now you have ability to load your own. So to do that is you use load validators. And if we look at a class that implements this method,
so just while you're searching for that, I know you also had, we're getting a bit of feedback here. Oh, no, it seems okay now. So I just noticed that here in your load runtime configuration, you're also doing some validation there. If you just flip back to the file you were on.
Right, so the reason for that is when this is happening, when we're going over settings, we don't actually have custom stuff loaded yet, because settings that we define may actually affect other stuff. So it's done very early on, and we don't always, we cannot always postpone the validation. So basically, if it's a very simple check, yeah, you may have to do it there. But again, it's the same as it was before. So if you if something happens, you throw an exception, and the process stops, and module is failed. I don't know if I answered your question.
No, I think so. I just wanted to clarify that we have this, validators section, but there's also a potential to do validation in the runtime configuration as well.
Right, right.
So, yeah.
It's meant to be very, very basic, so nothing fancy. So here's a load validators method, and what we expect, or what Smart-Proxy expects from it, is basically a map of validator names to validator classes. So the rest will be done in the DSL itself. So let me just go back to this. So for example, here you can see how we are validating the URL. I basically, I think I stole DSL for this from Rails. Again, it's very much it's quite similar to, for example, just below you see validate readable, except that you specify validator to use, and if there's no parameters, you can pass parameters, but in this case there is none. So you can just because it's a hash map, you have to pass something, so you pass true. Otherwise, it will be a hash map of parameters. Another interesting thing is that we now allow conditionals in validators, in which case they will only be executed if this predicate evaluates to true. And it uses the settings that we just defined just a step before as its parameter. So for example, in this case, we verify if environment's retriever that we're going to use is not the one that's based on the configuration file, puppet config file. So in this case, we need puppet URL parameter, and that's what the validator does. So below, I think I've done it just as an example to show that you can call built-in validators the same way. So here we validate file path in 3 parameters as the first 3 parameters. And again, no, it's used because there is also conditional in there. Again, we only gonna validate those paths if we're not using environments retriever based on a config file, because in this case we need access to Puppet API, in which case we need both URL and SSL related stuff. Alrighty, so we're done validating with validation, and the last step of this phase is that providers that were defined in use provider setting, and that's kind of common for that's the setting we use right now to define which providers to use. So one of the main changes, or one of the changes here, is that it now can be more than one provider. So we look at the setting and we resolve provider names to provider classes. Again, if we cannot find one of the classes or all, or any other issues there, this module will be failed, and we're not going to deal with it anymore. So it enters failed state. Once we resolved provider names, this process is repeated for each of the providers in order in which they were defined. One thing that differs, and I think it's actually the only one, is that provider settings are merged with main plugin settings. So instead of now trying to remember which plugin defines what setting, and I've encountered, well, there were a few times when I encountered this issue, and there were even bugs about this, related to this. So now you don't have to think about this. It's all going to be there. So one caveat is that if for some reason you have the same setting defined for both main plugin and provider, provider is not going to like it, and it's going to complain that there is a duplicate setting, and it will fail the process of loading. This is done so you do not accidentally override settings. And because it's kind of unidirectional, so only providers merge main settings, so there is no such check for the main class, for the main plugin. Oh, actually, yes. So that's again. So this is done for all of the providers, and once providers are loaded, this kind of concludes the first phase of the whole initialization and loading process. And we begin the second phase, which roughly consists of two parts. The first part is we figure out what classes we're going to use. I'm going to show you in a moment, and what their life cycle is going to be. And by life cycle, I mean, so every time we're going to use a given class, is it going to be a new instance, or should we just reuse one instance for every time we need that class? So basically, it's normal versus singleton. Actually, I skipped one thing. The change, the extension of the DSL that deals with defining this this runtime information, this what classes to use, etc. It's this low dependency injection wirings, and the whole thing is based on dependency injection. And again, if you've done or wrote a module or two, you probably already dealt with these. So this is kind of just uses it a bit more and extends it. So let's take a look. So we're looking at the main, no, we're looking at the legacy provider. So here it is. So if you remember, there were a whole bunch of settings defined in or appended when we were just loading the module. So for example, classes retrieval, environments retrieval, etc. So now when we're actually, we're gonna define various implementation for this retrievers based on what we figured out here. So for example, for environments retriever, it can be in API version 2, or it can be config file, but it's binary. So in case of API version 2, there's an implementation for that. So now it doesn't quite fit onto the screen, unfortunately. So this should be a bit better. So before this set of changes, you could only use class in dependency injection container wirings. So now you have a chance to define how a given class should be instantiated. The primary reason for that is that it makes testing quite a bit easier. So we don't have to rely on default constructor. And we can actually pass parameters right here, all the parameters that we need. So your classes not need to be aware of dependency injection at all. So the whole thing is made quite a bit easier on this end, although the wirings look a bit more complicated. Anyway, so here we pass parameters such as Puppet URL, various certificates, and that's actually it. So sometimes you will need to pass other dependencies. So for example, here, when we're using configuration file-based environment retriever, we pass dependency, which again is defined somewhere here. Yeah, right here, actually, Puppet configuration. So because the order is actually not as important here, just because this is evaluated during the first call to it. So like it doesn't really matter in which order these wirings are defined. Again, you see, it's probably one of the extreme examples. I don't think I have anything more complicated than this, but it just shows you how.
Can we see a simple one?
Yes. Let me take a look.
I don't know anybody else watching, but I'm struggling to follow a little bit. So simple one might help.
Okay, yeah, just let me take a look. This is the, well, it doesn't have any. So this is the simplest one, the one that doesn't have any wirings. Let me check. Maybe this one's gonna be a bit easier on the eyes. Yeah, this is pretty basic. So we just define environment retriever and class retriever. So just two things. I can open the class to show to you, but it's really nothing special. Just 3 settings, 4 settings in each, or parameters.
Oh, that's cool.
So notice that we use dependency. So which means that every time we request this dependency, this wiring, a new instance will be created for us. I'm not entirely sure what the accepted lingo for this is. I call this a label. So dependency injection container label. So these particular ones are used in the main module, in the the one that defines API, I believe. Yes, because this file is not in our control, so we do not instantiate it. So the older model of dependency injection is used, where we rely on setters. And so you can see that environment retriever and class retriever are injected here. So once we defined our wirings, so this mappings of labels to classes or labels to how they should be instantiated, the last step in this phase is to start services. And service can be, well, really can be anything. So the stuff that is of particular interest to us is things that run asynchronously to HTTP requests. Basically the ones that do not fit the request response pattern. And for example, you have something working in background and you need it running all the time. So in this sense, service is anything that implements a start method that takes no parameters. So all what we do is we go over services that were listed, and we just call start on each of them if start is defined. Puppet module doesn't use any of this functionality, but there's also I implemented a bunch of changes for the HCP, IC, the HCP provider, and that one does use service, namely we monitor Lisa's file for changes. So here is what it looks like. So pretty simple, start services, and we have a wiring label Lisa's monitor defined. Here it is. So we basically try to resolve this dependency, and when we find it, we call start on whatever we got back. Notice it's a singleton dependency, so there will always be just one instance of it. So first time we ask for it, it will be instantiated, and after that, it's just the same thing will be returned to us every time. So I think as far as DSL changes concerned, this is largely it. I updated documentation, although it still is work in progress with these changes, and I also showed examples of all these bits that we use now to define or predefine various stages of the initialization process. The work is largely done, although as I noted, some of the things, some of the names I'm not necessarily happy with. So these might change. I also think that some of the stuff can be a little bit too heavy, especially if you need just one or two changes. So I'm thinking that in this DSL that defines different phases, for example, load classes could potentially be accept a lambda or a block. So possibly the same for others. I'm not sure how useful that will be. So for example, dependency injection wirings probably not a good idea just because they're too heavy, and it would be useful to test them. And the current implementation where you pass a class name or a class actually allows for testing. I think that might be it. I can go a bit over Puppet module just to show the changes that were made there, if that's of interest. But as far as the core changes concerned, I think I'm done.
Cool. Oh, we've got echo again. Let me just mute you for a sec. Oh, no, it's gone already. That's very strange. So yeah, that's pretty cool. So just to summarize, we've got a lot of cleanup in just how we instantiate things, from what I'm hearing, just making it a lot easier in places to set it up. We've got really nice changes around the monitoring thing is entirely new, right? The services thing.
Yes, it's absolutely new. Yeah.
So I can see a lot of use for that, actually. That's really, really nice. I'm going to have to go and have a look at that file monitor, because I can see you wanting to monitor other files for changes as well as what can we have a look at that monitor, actually, because this is an entirely new piece of functionality. So yeah, it'd be really interesting to know sort of what its capabilities are.
Right. So right now it's confined to DHCP. In fact, just one provider, so it's not actually in the core. But again, this is very much heavily work in progress, because the implementation needs to support both Linux and BSD, and BSD uses a different implementation. So having said that, so we're using iNotify, and there is a Ruby gem that based on iNotify API, which is Linux specific. And really what we do here, that's probably the meat of this method, or rather this implementation. So we create a notifier for a particular file. We monitor all events. So this is very specific to ICDHCPD, because it essentially can do two things. The first one is it modifies file, deletes file, but every hour, I believe, and it's hard-coded, it recreates the deletes file from the data it stores in the memory. In this case, we actually need to notice this change, and I believe it's a move.
Right.
Well, one of the last things it does, it moves it back, so it renames it. So because of that, I need more than one thing.
Yeah. So the reason I'm asking, sorry, there's a slight ulterior motive here. Can we do anything? Can we monitor other things than files? Could we monitor, say, a remote API?
No, right now this is purely file system based.
Right. The reason I ask is there's a guy in the community I know who's writing a plugin for Isinga, and Isinga has status similar to ours. Whether or not the host is okay, right? Is it failing any health checks? It's a monitoring system, a very detailed one, and we thought it might be quite nice to just show the general health state of the host in Foreman. The problem is neither side wants to be the one to make the first move. Foreman expects you to hit an API in order to update that global host state or specific host status, And similarly, iSinger doesn't really want to make calls out either. It expects you to ask it for the state of the host, right? So I was wondering whether the Smart-Proxy might be able to keep an eye on iSinger for us and say, oh, this host is now failing. I'll tell Foreman as well.
Yeah, you can certainly write something like this. You need to be aware of, I don't know, all the network traffic you're creating and things like that.
Of course.
You
don't want to do it too quickly. I mean, as long as you know within a few minutes or something, it doesn't need to be every second, right? And I'm sure we could work out, me and Dirk could work out something where we could get like a bulk status or something for, all the hosts registered to this proxy or something. Because that would be easy. We already know that information on the Foreman side. So you make one request to Foreman saying, what are my hosts? And now you go to iSinger and say, what are the status of these hosts? You post it back to Foreman again.
It might be a use case for having some asynchronous tasks type thing.
Yeah, that was the other option. But I thought, well, since we've got some kind of basic thing kind of built into the proxy here, maybe we can use it without needing to extend dependencies further. But you're right, it might be too much for that. Anyway, it was an interesting thought. So we've had a question. Oh, sorry. Is there anything else you wanted to say about the monitoring?
No, that's really it.
Cool. So we've had a question from Alex Fisher, and I think I already know the answer to this reasonably well. But he wants to know if we're planning to use the Puppet Server 2.3 environment classes API for Puppet. Now, I'm pretty sure I know the answer to that, and I'm fairly certain you've got code using it right here in the demo, right?
So let me just open it. Puppet Labs, they recently updated their API to, I think they introduced rather a new API that returns classes or designed specifically to deal with classes. So the implementation that's currently in uses slightly older API. Let me just open it. So it's resource type APIs. With this, I think we need to support both. And eventually there will be support for Puppet class API. But right now this works with both the slightly older and slightly newer Puppet servers. I don't know if it answers the question.
So I think the question was specifically in 2.3. There's an environment and classes API, and I think that's different to the resources API. Is that right?
So the environment API existed since 3-something. So we're now using environment API version 3 in this implementation. I don't think there are any changes. At least I didn't hear about any of the changes in the environment API. There were, as I mentioned, Puppet added classes API, but we're at the moment relying on resource type APIs to retrieve classes. But again, it's
okay. As I understand it, they're planning to. They certainly say that this replaces the resource type API, so presumably we'll have to move to it at some point. But I mean, part of the point of this deep dive is to show off how we're now subclassing Puppet a little bit more, right? So it's easy to add these new features as we go forward.
Well, really, it will be down to just actually implementing this API and then adding a new module and then wiring it.
Right.
Because you, as a developer, plugin developer, it's pretty. You have so much control over how a given plugin, given set of modules, plugin plus providers is put together. So you can just override or create an implementation for the bit that you're interested in. So it's basically minimal work.
Sure. We haven't touched too much on actually the Puppet changes, have we? I mean, I think we've broadly covered the point though, the idea being that it was horribly complicated. I mean, you've shown the legacy version, which is horrendously complicated. And now, we've got much simpler modules per Puppet version.
Well, there's definitely that. So originally, because we supported, or still support actually, configuration based, then we support environments based on the configuration and based on Puppet API version 2. And it was very funky, it still is very funky how we determine which to use. And because of that, we need to parse Puppet configuration file. It kind of gets nightmarish and pretty hard to test. So because of all this, because the process now is broken up, and we kind of determine what we determine our configuration, what exactly we're going to use, and we can test that. And then each particular bit is implemented in its specific class. It's very easy to bring it or kind of define this runtime configuration that we're going to use. So because everything is kind of very well, the units are so small, so it's very easy to kind of glue things together and test the configuration and all this. So I think it's more manageable, although it's kind of a bit more in your face, so it can look a bit overwhelming.
Sure. I mean, there's a bit more sort of upfront overhead, but the maintainability going forward seems far higher. So yeah, I think you're onto the right thing here. Cool. So I don't see anything else coming in on the questions. Is there anything else you wanted to go over?
I just would like to mention that, and I already mentioned it, but just to kind of drive the point home, that the documentation for writing plugins, I updated it today. I still probably going to make more changes to it, but in general, it's accurate, and I think it's detailed enough to get you started on this or help understand code better. All the changes related to the process of plugin initialization and loading are contained mostly in one file. It's plugin initializer. It's in the core, so it should be, well, not necessarily easy, but at least you're not gonna have to look over all the code base to understand what's going on.
Mm-hmm. Mm-hmm. And just to clarify, is everything we've seen today merged into the proxy, or is there still patches pending?
Pending all of the changes.
Okay. So how can people help if they want to get this merged?
Reviews, tests, pretty much anything, any insight that.
Best leading question ever. What are the pull request numbers? And I will make sure we get annotations onto the broadcast.
Hang on. Let me open it.
I assume there's not too many. We're not going to be here listing numbers forever.
There are 3 separate PRs, although the last one, the DHCP one, actually references all 3 commits or all 3 PRs, including itself. So the one is Lisa's file no longer being parsed on every request. It's pull request number 409.
409, yeah.
So the Puppet related changes, use Puppet for all classes API, it's PR number 406.
406.
And the changes to the core, it's introduced configurable initialization of modules and providers. It's PR number 390.
390. Cool. I will make sure links are on the broadcast and on the mailing list for people who are interested to follow that up. I guess that brings us to the end of it. So unless there's anything else to cover?
Nothing on my side.
Well, it's been a pleasure as ever. I hope everybody watching live has found it useful. And I do encourage you to go and check it out. This looks like it's going to be pretty useful. So if you do have a little bit of spare time on your hands and you're interested, check out the patches, give us your feedback, let us know how it works for you. In the meantime, This will be the end of this deep dive. The next one scheduled, although I don't have a date for it yet, we're going to be looking at the facet system with Shimstein, who's going to be telling us all about why that got merged to core and how you can make use of it if you're doing things in Foreman core. Okay, with that, thanks very much for watching. Thanks very much, Dmitri, for joining us, and see you all next time.
Thanks for the invite.